Welcome to Your Math Explained, where we make math simple and clear. My name is Angela. Up to now, we've graphed the basic shapes of sine x, cos x, and tangent x. But in real problems, these functions are rarely just plain vanilla. They're usually shifted, stretched, and were flipped. That means we need to apply our knowledge of transformations on these original graphs. If you need a refresher on transformations, check out the video in the description before continuing with this one. We're going to use the general form here. So if you recall from our transformation video, the general form was y is equal to a times f of b times x minus p plus q. So the only difference here is that we've put in our function f, which for this particular example, we've put in sine. But it could be any of the trig ratios. Could be cosine, tangent, or even one of those reciprocal trig functions. And these parameters do the exact same thing as before. A is going to be our vertical stretch. But in the context of transformation of trig functions, we call that the amplitude. And recall that the amplitude is the distance between the midline and either the max or the min. And it really only exists for sine and cosine. B is our horizontal stretch. And what that does is it affects the period. Recall that the period is how long for the trig graph to start repeating its pattern. P is the horizontal translation, or the phase shift, and Q is our vertical translation, or the midline. So the relationship between this B value and our period P is equal to 2 pi over b for sine and cosine. And that's because the original sine and cosine graphs have a period of 2 pi. For tangent graph, the period is going to be equal to pi divided by b, because tangent has a period of pi. It's true that we could rely on coordinate analysis strategy to transform these trig graphs, but it can be very time-consuming to do so, especially with non-integer values occurring in these trig functions. So we're going to streamline this process for you so that you can handle these trig transformations with a solid process. Let's take a look at what we mean through an example. So here we want to sketch the graph of y is equal to 2 sine of x minus pi over 4. We're going to write down our important values. So a here is equal to 2, b here is equal to 1, p here is equal to pi over 4, and q is equal to 0. So this means our amplitude is going to be equal to 2, our period is going to be 2 pi over 1, which is still 2 pi. Our horizontal translation, or phase shift, is going to be pi over 4, and our vertical shift, or midline, is going to be 0. So usually what we want to do is we want to start with our midline. So we're going to draw a dotted line. So since our midline is 0, our dotted line is going to be right on the x-axis. And then next, we're going to draw 2 more dotted lines, one for the maximum and one for the minimum. So since our amplitude is equal to 2, then that means our maximum is going to be at 2. So we'll say 2 is right here, and that's going to be our maximum value. And then our minimum value is going to be equal to negative 2. So that'll be down right here. So then we know that this graph is only going to exist between negative 2 and positive 2. So now for the original sine graph, we will start at the origin. But because here we have a phase shift of pi over 4, that means we're going to have our graph shifted to the right by pi over 4. So we're going to say that this here is pi over 4, which means our next one is going to be pi over 2, and then pi will be here, and then 2 pi will be here. And then this next one is going to be 2 pi plus pi over 4. So this is going to be 9 pi over 4. So since our period is still going to be 2 pi, and our graph is shifted pi over 4 units to the right, that means we're going to have 0 be right on pi over 4. And then at 9 pi over 4 is when we have one full cycle. And now we can go ahead and divide the intervals in between evenly. So right in between pi over 4 and 9 pi over 4, we're going to be at 0. And then remember how sine has the values 0, 1, 0, negative 1, 0. Well, we're going to go ahead and draw that. But this time, instead of 1, our amplitude is 2, so it's going to hit our maximum value right over here. And then it's going to hit our minimum value right over here. And now we can go ahead and connect these dots. And this is going to be one cycle of our graph. So notice how it still has the shape of sine x, but we've shifted pi over 4 units to the right. And this still has a period of 2 pi, but the amplitude has now increased to 2 from the original 1. And now let's go ahead and draw the left side as well. So since each tick is pi over 4, we're going to go 2 over to the left, and that's going to be our minimum, which is negative 2. Go over to the left by 2 more, that'll be 0. Positive 2, and then back down to 0. So this is going to be another full cycle. And we can go ahead and label these x values. So this would be negative 3 pi over 4, and this here would be negative 7 pi over 4. The last bit that we need to do in order to finish this problem off is the fact that we're asked to sketch this graph for negative 2 pi to positive 2 pi. So we can see from what we've drawn so far, we're still missing a little bit on the left side because we're going to negative 7 pi over 4, but we need to go until negative 2 pi, which is right over here. But we know what's going to happen right over here because that is going to be again at negative 2. So then if we were to continue the pattern, it would go down to there. So now all we need to do is go ahead and erase the extra bit that we've drawn. So we can erase this part until we're at negative 2 pi. And then we're also going to erase this part so that we're at positive 2 pi. So this is going to be what the graph looks like within that specific domain. For our second example, we're going to sketch this transformed cosine function. So we're going to start the same way. We'll write down our a value, which is negative 3, our b value, which is 2, our p value. So notice how we need to get this in the general form first, which means we need to factor out the 2. So this would be negative 3 times cosine of 2 times x minus pi over 3 plus 1. So then our p value here is pi over 3, and our q value here is 1. So we're going to start the same way. We're going to draw our midline, which is 1. So let's say that is right over here. So that'll be our midline. And then because our amplitude here is negative 3, it tells us that our max and min are going to be 3 units away from the midline. So that's going to be 4 and negative 2. So let's go ahead and draw our 2 lines there as well. Next, we're going to use the b value to calculate our period. So period is going to be equal to 2 pi, which is the original period of the original cosine function, divided by our b value. So the period of this function is equal to pi. So that tells us we're going to have 1 full rotation within each pi interval. Now our phase shift here is pi over 3. So which means the regular cosine graph is going to be shifted pi over 3 units to the right. So that means our starting point is going to be pi over 3, which we will say is right over here. So that means this here is 2 pi over 3. This here is 3 pi over 3, or just pi. This one here is going to be 4 pi over 3. And since our period is pi, we know that we have a full rotation from pi over 3 to 4 pi over 3. Okay, and then we can just go ahead and label the left side as well. So this will be negative pi over 3, negative 2 pi over 3, and then negative pi. And then we're going to highlight our negative 2 pi over 3 as well, because from negative 2 pi over 3 to pi over 3, that's going to be another complete cycle. So now, because a here is a negative number, that means our graph is going to be flipped vertically. So the original cosine function has a 5-point summary of starting at 1, and then it goes to 0, and then it goes to negative 1, and then it goes back to 0, and then it goes back to 1. But because our a here is negative 3, that means it's going to get flipped upside down and multiplied by 3. So our 5-point summary here is going to be negative 3, 0, positive 3, 0, and negative 3. So now starting at pi over 3, that's going to be negative 3, which means we go 3 units down from the midline. So that'll be right down here. And then we know that since we have one full rotation ending at 4 pi over 3, that means we're going to be right over here. This is where we end our cycle. And now we can just go ahead and divide that interval up evenly. So if we cut that in half, then that means our maximum point is going to happen right in between. So that'll be there. And then halfway between the max and the min, we're going to be right over here at the midline. And then same thing right over here. And now we can go ahead and connect those dots. So it's going to look something like this. So this is going to be our one cycle. And then we can do the same thing for the left side. So we know that at negative 2 pi over 3, that is going to be one full cycle. So it'll end at the minimum point. And then halfway in between these, we're going to have our maximum point. And halfway between our max and min, we're going to have these 2 points on the midline. So this would be another full cycle. And now lastly, we want to sketch the graph of a transformed tangent function. So recall that tangent looks a little bit different. So we don't actually have amplitude when it comes to the tangent function. So a here would just be a vertical stretch if we have any, but our a here is just equal to 1. Our b here is equal to 1/2. Our p here is equal to pi. And then our q here is equal to negative 2. So we're going to do the same thing. We're going to start with our midline, which is negative 2. So that'll be right over here. We're going to draw our line. And then we're going to use our b value to find our new period. So the period here is equal to, and this time it's going to be pi because the period of the original tangent function is pi. So we're doing pi divided by our b value, which is 1/2. So our period here is equal to 2 pi. Our p value here is equal to pi, so that's going to be our phase shift. That means our graph is going to be shifted pi units to the right. So we're going to label our x value here, so that'll be pi. So that's going to be our starting point for the tangent graph. So remember, for the original tangent graph, we would have vertical asymptotes that are pi over 2 units away from our starting point. But because we've extended this period to 2 pi, now these asymptotes are going to be, instead of pi values apart, they're going to be 2 pi values apart. So that means that it will be 2 pi. So that is going to be our vertical asymptote. And then on the left side, that is going to be right at 0. And since our midline is at negative 2, our starting point is going to be right on the midline. And now we can go ahead and draw the shape of our tangent, which is going to look something like this. And then we can do the same thing on the left side. So this here is going to be negative pi. And then our next vertical asymptote is going to happen at negative 2 pi. So we can draw our dotted line there. And then our second cycle is going to be right over here. And it looks something like this. And now let's go ahead and do a quick recap of everything that we covered in this video. We learned how to apply transformations to these trig functions. Even though we're using the exact same general form, there were a couple of new terms like amplitude and period, because those are the new terms that relate to trig functions. We learned that the period is important to consider because it helps us with our graphing efficiency. And we can calculate it by taking 2 pi divided by the b-value for sine and cosine graphs, and pi divided by the b-value for tangent graphs. And we learned what process to follow to graph these multi-transformation trig functions easily. And now it is your turn to give this a try. Can you sketch the graph of this sine function on the screen here using what we covered in this video? Let us know in the comments below how you did and whether or not you'd like to see more content on trig transformations in the future. That's it for this video. If you found it helpful, remember to hit that like and subscribe. And if there's a topic you'd like us to cover, make sure to drop it in the comments.